Hello, Algebra 2 folk. We are on lesson 9.4. We're looking at our samples in preparation for a 9.4 quiz. So let's do some practicing. So for samples 1 through 3, we're going to want to make sure that our textbook page 557 is available, or the notes for our special angle trig functions and their values, because we're going to need to use those values to solve the problems that we are asked to work. So on sample 1, we are asked to figure out what is the angle whose tangent is negative square root of 3. We're going to find out that it's 300 degrees. That also can be written as negative 60 degrees. Let's see how that works. We're going to go ahead and mark this in as sample 1. Well, when we look on page 557, we're going to see that it shows that the tangent of 60 degrees is the square root of 3. But we want to know where is that angle when tangent is negative, because we see that we need to find the angle whose tangent is negative root 3. Well, here's where our angle whose tangent is 60 degrees, where it's positive. Where tangent is negative will be down in quadrant 4, because tangent is opposite, in this case negative, over adjacent, which is positive, or our y over our x. Negative over positive, which is negative. So we see that tangent is negative in quadrant 4, so we'll need to open our angle from the x-axis 60 degrees, which we then can report our answer is negative 60 degrees, since when we are going clockwise from the x-axis, that's a negative value. Or we start on the x-axis and proceed counterclockwise, and we have to figure out what then is 360 minus the 60 degrees to arrive at our positive degree measurement would be 300 degrees. So we're always going to be thinking about that coordinate plane and using page 557 to find the values of these particular inverse functions. All right, sample 2. Sample 2 asks us to figure out the inverse of cosine being negative root 2 over 2, what it is. And so we're thinking, well, what is the angle whose cosine is negative root 2 over 2? Well, page 557 shows that the cosine of 45 degrees is positive root 2 over 2, and that's this angle right here. But where is cosine negative? Well, cosine is negative over here in quadrant 2. And in quadrant 2, when we are forming our 45-degree angle with the x-axis, we're asking, well, what is the angle then in standard position? Well, we don't quite get to 180 degrees. We have to take 45 degrees off of that 180 degrees. And so our answer to the question, what is the angle whose cosine is negative root 2 over 2? It would be 135 degrees, since 180 minus this 45 degrees is 135 degrees. Sample 3, we're still on page 557, using that information for those special angle trig functions to answer this question as well. So on page 557, we see that the angle whose sine is 1/2 is 30 degrees. But we want to know what is the angle whose sine is negative 1/2. So we have to ask, where is sine negative? Well, here we are with 30 degrees where everything is positive. Our quadrant 4 will be where sine is negative. Remember that our sine is y over r, so negative y over our positive r would give us a negative value for sine. So we can either answer the question that the angle whose sine is negative 1/2 is negative 30 degrees down here in quadrant 4, or we can answer the question 360, take away those 30 degrees to give us 330 degrees if we go counterclockwise, starting at the x-axis and proceeding all the way around here to 330 degrees, because the last 30 degrees would bring us back to 360. So I can answer it either way, either positive 330 or negative 30 degrees. All right, sample 4 asks us a little bit different question and asks us to find the angle in the triangle here. First thing I'm going to do is I'm going to label up my triangle with adjacent, opposite, and hypotenuse. I'm showing that in red because I've added that after the fact. And then I'm going to say, well, which trig function should I use to find this angle? And I notice that I have been given the opposite and the hypotenuse lengths. So opposite over hypotenuse is sine, so I'm going to say the sine of this angle theta is 4/5. 4 for the opposite over 5 for the hypotenuse. Then I'm going to rewrite this equation in inverse form, so I'm going to say the angle whose sine is 4/5 is theta. So when we're rewriting an equation in its inverse form, we're going to switch the theta and the value for sine. So the angle whose sine is 4/5 is theta. I'll use my calculator to work out that inverse function. It gives me a value that looks like this in degrees on my calculator. It'll continue on. I'm going to round off to the nearest hundredth. So angle theta then would be approximately 53.13 degrees. Example 5, we're doing the same process. Find angle theta. First, we label up our triangle with which legs are adjacent to the hypotenuse, which legs are adjacent and opposite, and the hypotenuse. So remember, we find the labels on our triangle by looking at the right angle. Opposite the right angle is hypotenuse. Next to the angle theta, or whatever angle is of interest, will be the adjacent leg, and opposite the angle theta that we're interested in will be the opposite side, the faraway side. All right, cosine of theta then is 7/25, adjacent over hypotenuse. I chose cosine because I know the adjacent and the hypotenuse lengths. Then I'm going to write the inverse function. So the angle whose cosine is 7/25 is theta. And then I'm going to use my calculator to find that inverse function value. The angle whose cosine is 7/25 is approximately 73.73979. And it goes on for quite a ways. We'll round that off to 73.74 degrees. For our last sample today, we're solving for theta once again. This time we're given an equation. Sine of theta is equal to negative 0.45, and we're to find the value of theta. We have to find the value of theta, it says, though, in between 180 and 270 degrees. That's going to put it in quadrant 3. So we're going to need to find our answer in quadrant 3 here. First step, rewrite this equation in its inverse form. So angle whose sine is theta, the angle whose sine is negative 0.45 is theta. We're going to reverse the sine and the negative 0.45 as we rewrite this in inverse form. Using our calculator, we'll find out that theta is negative 26.74 degrees. And that is not our final answer, because that actually gives us an answer here down in quadrant 4. The negative 26.74 is down here. But we have to be in quadrant 3, so we need to find the angle in quadrant 3. That is the reference angle, 26.74. And so down here in quadrant 3, 26.74, we will need to add that to 180 degrees to find the angle measurement in standard position. 180 takes you all the way over to the x-axis, and then we need to go 26.74 more to be here in our third quadrant. So we're going to add those together to get 206.74 degrees. And that completes all of our work for the samples for lesson 9.4. Please go ahead and proceed on to the quiz, and we'll see you next time.